We are discussing increasing and decreasing functions. And also today we will finish 2.4, hopefully, the transformation. Yeah. So this is very fast, increasing, decreasing functions. Let's share the page. And I have to open OneNote. All right. So we are doing this, right? Yesterday. Active, decreasing, on, constant, on, etc. Right? Okay. So the next one is average rate of change. So the average rate of change. So B is average rate of change. So rate of change is actually speed. So rate is speed, right? So for example, what is the distance between LA and San Francisco? About 400 miles, 380. The distance between LA and SF is, let's just say 380 miles. Okay. And how long does it take you to get there? By what? Maybe by plane, right? But the plane, it has takeoff and landing. No, plane is actually 1 hour only. Yeah. So if you drive, how long does it take? 6 hours. It takes 6 hours. Does it include your stop at the burger place or no? Restaurant break? No. So this is if you drive straight. It takes 6 hours to get there. What is the average rate? So this is talking about speed, okay? So this is also slope. So average rate of change. So you could equal this to speed if we're talking about car, or slope. Later on, we will talk about it. So how would you answer that? Well, it's just going to be 380 miles divided by 6 hours. So what is 380 divided by 6 approximately? 380. Yes. Approximately 63.3 miles per hour. Do you only drive 60 miles per hour? No, but sometimes when you get to San Francisco and when you're trying to exit LA, it's traffic, right? So that's why it takes 6 hours. Yeah. So basically, the average rate of change. So average speed is distance traveled divided by the time. Okay. What about the average rate of change between functions of the function y equals f of x between x equals a and x equals b? So let's write that down. So what about the average rate of change of the function y equals f of x between x equals a and x equals b. So I'm going to draw it here. So if you have a function, okay, so it looks like this, and then you have this function here. This is a, this is b. Okay. So this is f of a, and this is taller, sorry. This is f of b. So the average rate of change is the slope, which is, what is the slope of this function? Rise over run, what is your rise? So this is your rise here, which is what? Yes, so this is f of b minus f of a, and your run is b minus a. Yeah. So this is the change in y divided by change in x, which is f of b minus f of a divided by b minus a. And if you see this, that this is the slope of the secant line. Between a comma f of a and b comma f of b. So average rate of change is the slope. So basically average rate of change is the speed and also the slope of the secant line. Alright. So when you think about average rate of change, it's the slope. Speed, slope of the secant line. Alright. Now, what is the secant line? And the other thing is a tangent line. What is a tangent line? What is the secant line? Any idea? Yes, so it touches the graph of the function twice. That's right. Yeah, right. So this is your secant line. It should touch these 2 points. Yeah. So it's the slope of the secant. All right. So this is a straight line supposedly. So this is a secant line, the slope of the secant line. Yeah. So if you have a line here, then the slope is right over run. So what is the secant line? So a secant line touches the graph of a function. How many times? Twice. So you have a secant line here. So you have you have P, Q. So the secant line connects P, Q twice. What about a tangent line? It touches the graph of a function. How many times? Function 1. Okay, yeah, you learned in geometry, right? So let's just say you have a circle in geometry. This is a secant line, PQ. And the way I draw it, it touches more than once in one. I only want to do the touching line. So this line L is the tangent line. It touches only at 1 point. So for example, line L. Example, PQ. Right? Okay. Are we okay so far? And then in geometry, what happens? What did you prove? Between the radius is perpendicular to the center line. Yes? We proved that in geometry. Yes, no? Okay, good. So, so you know what secant line is, what tangent line is, and this is average rate of change, not instantaneous rate of change. Yeah. Now, instantaneous rate of change is discussed in calculus. So what happens in calculus later on is if you're taking P and Q very, very close to each other, so think about this. If these 2 points, P and Q are very, very, very close to each other, what happens? So B, if B minus A is close to 0, then your slope will be not the average rate of change, but the instantaneous rate of change. Yeah? Okay, so you'll talk about it in calculus. Okay, so for example, are you guys ready with this? Yes? So next. All right. So for example, determine the average rate of change. All right. So number 1, this is the function f of x is equal to x plus x to the 4 between x equals -1 and x equals to 3. So how do you answer this? Well, the average rate of change. By the way, did everybody turn in their take-home test? Is equal to what? So who didn't turn in their take-home test? Yeah. Can you please turn it in now? So this is f of 3 minus f of -1 divided by what? 3 minus -1. Yes, good. So what is f of 3? Okay, thank you. Okay. Yeah. So what is f of 3? 3 plus 3 to the 4, right? Yeah. So 3 plus 3 to the 4 minus -1 plus -1 to the 4. So it's actually easier to do it on your head. 84 minus what? Divided by 4. So this is 84 minus what? 0? Okay. Divided by 4. So our answer is 21. Good. Okay. So the second one, f of x is equal to 4 minus x when between x equals 1 and x equals 1 plus h. Yes.
Out of the 2 that are given, x equals -1 and x equals 8. How do you know which one is that A?
So A is always the smallest one.
A is always the smallest one.
Yes. So the A is the smallest one. So this is your A here, and this is your B. Yeah. Or actually, it doesn't matter, right? Okay, so think about this. What is average rate of change? It's slope. So if your line looks like this, does it matter which one you call the first point and which one you call the second point? No, it doesn't. So here I call the A the smallest one, B is the larger one. But it actually doesn't matter if you want to find the slope. So if I were to write it as f of -1 minus f of 3 divided by -1 minus 3, this will give me the same answer. Also.
Well, the most important thing is that whatever sign you put A on, you have to put it on the denominator the same way.
Well, yeah, it's f of, if you call it B and this is A, then f of B minus f of A divided by B minus A. Yes, you get it. Alright? Okay. So it will give you the same answer if you were to call these B and this A. It doesn't matter. And this is slope. Alright? Okay, so now what am I going to do with my number 2? Well, in this case, this is 1 plus h. This is a what? Binomial? And then I have to square it. So we probably want to calculate this first. So f of x we know, but when x is 1, f of 1 we know. F of 1 plus h, we probably want to calculate it first. So f of 1 plus h, just because this is binomial. Right? What is f of 1 plus h? 4 minus 1 plus h squared. That's right. So what is this? 4 minus, what is 1 plus h squared? 1 plus 2h plus h squared. Yes. So this is 3. Yes. So 3 minus 2h minus h squared. Yes. So I'm just doing this. I'm just breaking it down because it is a binomial. That's the only reason. Yeah. So what is the average rate of change? Okay. This is f of 1 plus h minus f of 1 divided by what? 1 plus h minus 1. Yes. Okay, so I'm sorry, I have to continue here. So continue here. So what is f of 1 plus h? Oh, we already calculated. Alright, so I'm just going to write it in. So 3 minus 2h minus h squared. This is the one we already calculated. Minus, what is f of 1? 4 minus 1 squared, 3, divided by h. All right. So the 3 cancel? Yeah. So what am I left with? So the 3 cancel. So this is 3. So the 3 cancel. 3 minus 2h minus h squared minus 3 divided by h. The 3 cancel. This is negative 2h minus h squared divided by h. That's it. Simplify, we divide by h. So what do I have? Negative 2 minus h. So, good. Okay. Yes, no? Okay. All right. What happens if h is 0? What's the answer? Negative 2, yeah. So it's basically the derivative of f of x equals to 4 minus x squared when x is equal to 1 is negative 2. So later on, yeah, so this is later on connecting to calculus. Okay, that's it. I'm done with average rate of change. So do we understand what average rate of change is actually? What is it? Well, what did we calculate so far? The slope, right? So the slope, rise over run. So this is rise over run. And also what? Speed. Yeah? So rise over run or speed. Yes? Okay. So I'm done with complexity unless you have any questions. Are we okay so far? All right. So let's continue. Let me save this first. File, save as, save as. No. Where did I put it? Documents. What is it? OneNote? No. Personal. Oh my gosh. Not this next is the word. Okay. Okay, good. Now, I want to have a new page. So this is 2.4. Transformations of functions. 2.4. Transformations of functions. So let's talk about vertical shift first. Yeah, so we always start with the basic functions. Remember the basic functions before? What's the basic function? Y equals x, what else? Y equals x squared. Before, what is it? Y equals x cubed. Y equals the square root of x. Y equals absolute value of x. You know this? And then what is the last one? Y equals 1 over x. And then y equals the greater than 0 x. Yeah, so that's what we did yesterday. Right? Or 2 days ago? Oh, yesterday. Now, so this is your basic function. So, for example, later on, we are going to shift it, reflect, stretch it vertically, stretch it horizontally, and then and we start with the basic function. Okay. So the first one is vertical shift. Vertical shift. So this is the form. Y is equal to f of x plus k. Alright. So what do? We shift up if k is positive. And we shift down if k is negative. All right. So what do I mean by that? Well, suppose this is my function, y equals x squared. Okay. What do you think happens when I put y equals to x squared plus 4? You shift or up? Yes. So this is y equals x squared shifted 4 units up. Does it maintain the shape? Okay, so no change. You just translation. Translation is you just move it. We just move it and no change in shape. Okay. Now what about y equals to x squared minus 30? Yes, so this is y equals x squared. Shifted 3 units down. We don't have to graph it, do we? No, right? Good. Now, the second one is horizontal shift. Alright. So this is f of x plus k. Y equals f of x plus k. Now, the form is y is equal to f x minus h. So do you notice the difference? Before I have f of x plus k. Where is k located? Outside. Yeah, outside the parentheses with x. So maybe I should write a note here. Look at the k. The k is outside the parentheses, so it affects the y. So it affects vertical component. Yeah, so maybe you want to write a note. K is outside the parentheses. So affects y. Okay, now look at this. Where is the h? Inside the parentheses, so it will affect your x. X is horizontal. Yeah. And the other thing to notice is I have plus k here, but I have minus h here. Yeah. So it's the same thing. We shift right if h is positive, and we shift left. So shift left if h is negative. All right. Now I'm going to write a note also here. So it is always true. Yeah. So h is inside parentheses. So next to x. Affects x. X is horizontal component. Yeah. Now, compare again with y equals x squared and y equals to x minus 2 squared. What do you think happened if I have y equals to x minus 2 squared? So this is what? Y equals x squared shifted. Shifted what? Right? 2 units. Why right? Because h is 2. So your h here is positive 2. Remember your function is f of x minus h. So your h is 2. So you shift it right 2 units. Now what about if I have, so let's label this number 1, number 2. Y is equal to x plus 3 squared. So what does the graph look like? The graph is y equals x squared. What about the shift? Shifted left. How many units? 8 units. Why is it left? Why is it left? What is k here? Oh, what is h here? Negative 3. Yeah. So you have to notice your difference here. Okay. Because in my form here, I have h is x minus h, not x plus h. Yeah. It's like in the circle, in the ellipse, everywhere. Yeah. In the parabola. Remember, if you had a parabola, you have y is equal to 5, x minus 2 squared plus 3. What is the vertex? 2 comma 3. Right. So it's not negative 2 comma 3, it's 2 comma 3. So before it was at 0, 0, and then it shifted 2 to the left and 3 up. Right? So it's the same thing. We shift it right to units, and then you shift it up how many? 3 units. Yes. All right. Okay. You got this? So this is not only true for parabola, it's true for circles, true for x cubed, true for absolute value, true for square root. So if I have y equals to square root of x minus 3, what happens to my graph? So this is the graph of y equals to what? Square root of x shifted what? Shifted what? Right or left? Right? How many units? Yes. Okay, so it's not only true for parabola, it's also true for others. Yeah. Good. All right. Reflection. So C. Okay, so I'm sorry, this one's too small. And I'm using red also. Can you guys read it? Number 3? Yeah, okay. Good. So next, reflection. Yeah. Do we want to graph it just to make sure or no? You're okay? Maybe later on. Yeah. This one shift is easy to imagine. You just move up, move down, move left, move right. Yeah, so later on we will graph. Now the next one is reflection. About x axis. Okay. Does it affect your y or your x? Your y, yes. Okay. So, let me So if I have a graph that looks like this, and I want to reflect it about the x-axis, how does it look? Somewhere here, right? Oops, not quite. Okay, well, you can use your imagination. But if you reflect about the y-axis, about the x-axis, what is affected is the y. So if this is x comma y, what is this coordinate here? Yes. So you see that the y changes. So this part becomes -4. Okay? So that's the reflection. So this is y equals to f of x. This is equal y equals to negative of f of x. Yes? All right. So that's the reflection. Y equals to negative f of x. So what do? This is reflect about x. By the way, where is the negative located? Is it inside the parentheses or outside? It's outside, so you know it will affect your y. Outside y, inside x. Okay. Now, there is also another reflection, which is about the y-axis. So reflection about the y-axis. So if I draw again, okay, so if my graph looks like, I didn't give you examples. Let me give you examples. What about graph y equals to negative square root of x? What does the graph look like? This is the graph of y equals to square root of x, and then reflected about the x-axis. Okay. So maybe we should graph it. All right. Okay, let's see here. So 2, 3, 4. All right. X, Y. So how does y equal square root of x look like? Do you remember? Just tell me the shape. It is a what? A parabola, but on the side, and it's only half. Yes. Okay. So 0, 0. Okay. 1, 1, and then 4, 2. Yes. So this is your graph y equals square root of x. Right. Now, if I reflect it, then what happens? Well, before I have 1, 1, well, 0, 0 still stays 0, 0. Then if I have 1, 1, what's the next one? 1, negative 1. So this is 1, 1, 4, 2. My reflection is, maybe I should use 1, negative 1. What about the next one? 4, negative 2. So practically what we did was we replaced the y by negative y. Or we multiplied the y by negative 1. Are we okay so far? Yes? Okay. Good. Alright, so this is y equals to negative square root of x. That one. Yes? Now, reflection about x-axis. So if I have my graph, what does my graph look? About y-axis, sorry. Looks like this. How do I reflect it? Well, it's on the other side. I don't think it's what is it called? Symmetrical at all. It's kind of unsymmetrical. Maybe I draw that first and then I draw the reflection. There. Okay. So let's just say this is x, y. What will this be here? I'm sorry, this is quite symmetrical. What is it? Negative x, y? Okay. All right. So this is y is equal to f of negative x. Okay. So this is reflect about this y. All right. Yeah. Okay. So what about y equals to square root of negative x? How do you think it looks? y equals to square root of negative x. This is the same distance also, supposedly. Any idea? Yes, so it's reflected. So this is y equals square root of x reflected about the y-axis. Okay, maybe it's right here. All right. Well, if I reflected about the y-axis, let me see how it goes. And yeah, any other colors? So if I reflected about the y-axis 0, 0 is still 0, 0. How about 1, comma 1? Then it will be negative 1, comma 1. How about 4, comma 2? Negative 4, comma positive 2. All right. So this is the reflection. So this is y equals to square root of negative. So this is your original. Maybe you might need to do this. This is my original, okay? Original. Good. Now, the next one, let me wait for you. So we will talk about vertical shrinking and stretching, and horizontal shrinking and stretching. Yeah. So we'll talk about that. We're done. Okay. Any clarifications so far? Are we okay? Okay. So later on we have an example and we'll combine those, right? So the next one, CDE. So E, vertical stretching and shrinking. Yeah. So what vertical? So if this is the y equals to c times L. All right. So it's outside. The c multiplied by L of x, and the c is outside. Okay. So if c, absolute value of c is greater than 1, then y equals y is vertically, then L of x, L of x is vertically stretched. By a factor of c. Okay. Now, if c is between 0 and 1, I'm talking about absolute value of c. F of x is vertically compressed or vertically shrunk by a factor of yes. 0 is less than absolute value of c less than 1. Yeah, it's not really clear. Let me rewrite this part. So it is 0 is less than absolute value of C is less than 1. All right. Now, for this, let's use the trigonometric function. It's really easy to see. Yeah. What trig functions do you want to know? Sine and cosine? So let's use y equals sine x. All right. So let's just draw one period of y equals sine x. Actually, I don't use this. Let me just use this one. All right. So let's draw one period. Okay. So this is 1. And let's say this is pi, and this is 2 pi. And this is pi over 2. This is 3 pi over 2. So 1 is approximately here. Oh. Okay. Oh, undo? Okay, thank you. You're right. So this is, where is my 1? 1 is approximately here, and here. So how does the sign look? It starts where? 0? Yeah. So here. If you don't know, it doesn't matter. Okay? It doesn't matter. But I just want to show you how the graph looks like. What does it mean to be vertically strong or vertically stretched? It should be smooth, right? I believe some of you are taking tricks at the same time, right? Concurrently. Okay. Who are taking tricks right now? Oh, okay. Quite a lot. So you know these, right? Wait for something. Good. Now, if I say y equals to 2 sine x, okay, then what happens? Is it shifted? No. This is y equals sine x vertically stretched by a factor of 2. So that's the shape change. Well, yes, because you have to stretch it. It's not like you reflect it or translate it or shift it. The shape is slightly changed by a factor of 2. Then what would you say happening here? This is no longer 1, but 2. So the amplitude is increased, right? And this is no longer -1, but -2. So this one right here. So this is -2. So this is y equals to 2 sine x. So y equals 2 sine x. The blue one. So that one is y equals sine x. Okay. Now what happens if I have, okay, y, number 1. What happens if I have y is equal to half sine x? What type of transformation do I do? Yes, this is y equals sine x. What happens? Vertically compressed or vertically shrunk by a factor of half. Yes. That's right. Then what happens again? The amplitude is half. Oh. Undo. Oh, there you go. Right? Undo. Half. So this is half also. So now this is not as high. So it's only going to be here, here. So you see, it's sort of, you sort of like compress it. So this is why equals in half. Okay. So if this were a rubber band and you have these three, if it is vertically stretched, it's not stretched. If it's vertically compressed, it's not compressed. Something like that. Yeah. All right. Questions? Is it clear? Sort of? Okay. So the shape slightly changed. Right? The general shape doesn't, but it slightly changed. Now, we also have horizontal stretching and shrinking. Yeah. All right. So F. Are you guys ready? Okay. So F. Horizontal stretching and shrinking and compression. Okay. So, what do you think the form will be? This is horizontal. So, where should it be? Inside the parentheses. So, y is equal to f of cx. Should I just use c or did you use a different one? Kx? Oh no, I don't use k. I haven't used k. So c, f of cx. So you know, oh, this is inside. It will affect your quote. Now, this is a little different. Okay. So if c, absolute value of c is greater than 1, this is not horizontal stretch. This is horizontal shrink or compression by a factor of 1/2. So it's smaller. Oh, I was using this undo. The undo button. So it's shrunk. Yeah, if c is greater than 1, so the period gets smaller. So if you know about sine and cosine, well, we'll talk about it in a little bit. Yeah. And then if c is between 0 and 1, so 0 is less than, absolute value of c less than 1, this is a horizontal stretch by a factor of 1/c also. Okay. So I'm going to still use y equals sin x. Alright, so let's use y equals sin x. And then what about y equals to sine 2x? Well, what is y equals sine 2x? This is y equals sine x. Horizontally shrunk by a factor of half. Alright? So, okay, so what do I mean by that? Okay, let me graph this. So this one. Okay, so here I have to draw probably a little longer. Let me draw a little longer. Okay, so here. Okay, so this is pi. This is 2 pi. Oh no, this is not in the middle. Here's the middle. So this is pi. This is 2 pi. This is pi over 2. This is 3 pi over 3. I'm sorry, this is 2 pi, this is pi. That's what I was going to do. That's 4 pi. This is 8 pi. Okay. And then if this is pi, well, I think the scale doesn't really matter, right? I'm going to put a 1 here, even though it's pi is what? Yeah, approximately 3, right? So actually the scale here is not too good because I draw 1 here and this is 3. So it should be 3 times, right? But I don't have space. So I apologize. Yeah. All right. So this is pi over 2. This is 3 pi. So I'm going to grab the sine graph again. So as I said, the vertical is not really into scale. Here, here, here. Why do you think it's bigger? Let's see a little bigger. Okay, something like this. This is your original graph. Y equals sin x. So this is one period of y equals sin x. Yeah. Now, what about y equals to sine 2x? What do you think? If I say it will be horizontally shrunk, so what do I do? Any idea? So before if it is vertically shrunk, what do I do? Compress it, right? What about if it is horizontally shrunk? Compress to the other side. By how much? By a factor of what? Half. So it becomes half the size. So if this is my original, now it's half of it, so it's going to look like this. So the height is still the same. There is no change in height. But what happens horizontally? It's just got shrunk. Right? It just got pushed. This is y equals to sine of 2x. So do you get the amplitude is so great, it is so 1 that it just got switched horizontally. Okay. Now, can you guess what happened when you have y is equal to sine half of x? What happens? This is the graph of y equals to sine x. Horizontally, what? Yes, expanded, horizontally stretched by a factor of, is it a factor of half? No, a factor of 1 divided by half, which is 2. Yeah, 1 over half. That's why I put 1 over c here. Did you see this? So it's 1 over half. So it is 2. And you see, well, before it ends at 2 pi, so now it ends at 4 pi. Yes. All right, so it looks like this. So this one is y equals to 7. Did you do this in trigonometry yet? Yeah, are you doing it or did it pass already? Oh, not your class? Oh, okay. You haven't done it. You haven't done it. Okay. This is. Oh, okay. Okay. Then later on, you probably have to graph y is equal to 3 times cosine 5 minus. And then what letter do you use? K. K and what? Oh, it doesn't matter. It doesn't matter. This is cos x minus 5. So you'll probably have to x minus 5 plus 2, something like that. So this is a horizontal shift. So you have to grab the key points and then do something with it. Yeah. Okay. So I have 3 minutes. Last week. Yeah. So what did we do so far? Yeah, I don't have time to do examples at all. But tomorrow I will do examples. Yeah. Now, what did we do so far? What type of transformations do we have? 6 types. What are they? Shift. Which one? Horizontal, vertical. Vertical. F(x) plus k. Right. Horizontal. What is it? Y equals to f of x minus h. And then reflection about the y-axis. Y-axis, so imagine, visualize it. Y-axis. So here, here. So what is it? Which one is affected? Y equals to, no, y-axis. 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 F of negative x. Yes, Jacob? It's okay. Yeah, I remember. Okay, hold on. And then what about the reflection? The other reflection about the x-axis? Y equals to negative f of x. Good. And then we talk about reflection, stretching and shrinking. Yeah, let me call the roll now. And did you guys turn in your take-home test? Kevin and Benito? Yes. Yeah, I don't mind. Let me see. Here, you can look at it or take a picture of it. It doesn't matter. All right, so Renee's here, Sophia is here. Jose Ayon, not here. Jocelyn's here. Elizabeth's here. Marissa's here. Brian Cisneros, not here. Yes, is here. Alex is here. Roger is here. Jose Garcia is here. Kevin Garcia is late. I need your table test, Kevin. Natalie is here. Jace is here. Gerardo is here. Sandra's here. Andy is here. Edgardo absent. Yanni is here. Valentine is here. And Maria is late. Are you late? Yeah. Is late. Joshua is here. Is here. Fernando. Nicholas is here. Brittany is here. Diana is actually here. What time do you want to see me today? 12 in my office. G5111N. Do you know my phone number? Because sometimes, yes, because sometimes the door is locked, so you have to call my phone. Can you come a little bit earlier just to make sure the door is open? To the secretary, close it. Oh, okay. All right. Then that's all. Yeah, you're fine. Jacob's here. Andrew Reyes. Jennifer's here. Jose Rios here. Sonia here. Marisa is late. Steve's here. Jose is here. Jack's here. Chow is late. Yeah, Alex. Okay, good. So, table test. Everybody turning their table test? Yes. So, tomorrow you guys are going to bring a portfolio, right?
I was going to tell you, because I missed that you can't go well. They told me it was an option.
No.
Because I asked you, like, oh, did you make your portfolio?
Homework is online. This is take-home test. This is not on. This is not homework.
I mean, I just the one that was online. I think you gave out sheets like that.
Why you didn't ask somebody else?
Because I never saw it.
No, this one I got up there. This one has to ask yourself though.
Well, when I did it, it didn't have any answers. It was just like, you turn it in and give me a grade.
This is the take-home test online. No, this is not the one I assigned. Hold on, let me copy later. Let me take this out. Okay, so let's close this.